I want to start by welcoming all of you and introducing myself. My name is Tibea Ciprian, and today I will be your presenter for prestressed. And I want to ask your pardon for my voice, but I caught a little bit of flu this weekend, so I'm not in like tip-top shape. But I will do my best, so you won't see any, you know, troubles, hopefully, in hearing me. So let's start with pre-stress. Now, this will be your welcoming screen. Of course, some of you here are familiar with pre-stress. Others maybe see it for the first time. That's why I will go through the boring stuff also, but the more expert users will also have content to watch. So as you see, is Eurocode based, and you can select from this drop-down menu if you want to use the British, Danish, Swedish, Finnish, or Norwegian annexes, or if you would like to just go with the standard Eurocode. Usually I go with the standard because it applies to all of us. So then you are greeted by this other window where you basically have to input your data for your model. Now, I will just name it example, I don't know, 111, and we will give it like a length, and we can choose the section, right? So choosing the section, we have two possibilities. Either go with the standard, and then we cannot modify the sections, or we can go with the non-standard, and then we can basically create whatever section we want. So in this case, I went with a rectangular solid section, and it asks to give it a name, example 111, and then the measurements, you know, like in millimeters. So let's go with 600 or 500 and 300, and we click add. Okay, and then it will use this this section. Now, of course, the beam type, for this example, I went with the constant section, but we will see towards the end of the webinar that we can go with the slope type beam. We can either create, you know, like a multi-section beam. So yeah, we have all sorts of options in this regard. Now, this part, the topping, is basically where I tell the software if I want a topping or I don't want a topping. So if I want a topping, I will go with the same name and just click add, because automatically he identified my section. And as you see here, if I press those two arrows, it will basically explain all of those parameters which can be found, you know, what dimensions are they referring at. So I'm satisfied with the topping that it added by default with the thickness of 100. So I just click add and OK, and then again OK. So now we have created our first example, which is a simple rectangular beam with a topping, and we click add project. Now, as soon as we click that button, we are greeted by this window where they automatically, you know, select those three options, which is create default load combination, generate dead loads, and create support. And we can click or unclick the fire load combination, depending on what we want for that model. So I will just leave it unclicked for now and click OK. So we can keep things as simple as possible for our first model. Now, if I go a little bit down, I see my name, which is X111. And I see an overview, a longitudinal and a transversal section of my beam. So in this case, I see also a lot of new tabs in this window. So this is the main reinforcement tab. Then I have the steer up reinforcement tab, reinforcement details, where I can set the cover, the diameters used by defaults, if or not I want to use regular spacing in layers, steer ups, etc. And here I have the calculation settings, where I can modify, for example, the surface between my topping and my beam. Like I can set it for like very smooth, rough, or indented. Usually when we select very smooth, the interface between the topping and the precast element the cohesion will break, and we will get a warning message. So when that happens, usually we return here and we select a more adhesive surface, like rough or indented. Here, mostly for Danish, is the consequence class, the snow zone, and so on. And for the shear calculation settings, like when we deal with a beam that has steer-ups, of course, we want to calculate the shear by using the shear reinforcement, but we also have elements like hollow core slabs where we don't have any shear reinforcement. And in those cases, usually the software will identify automatically that it's a hollow core element, and it will switch automatically to this shear calculation without shear reinforcement. And then, of course, some new options will open, but we will tackle those when we get there. And then we have, of course, the fire tab, where we should, give like the fire time in like 60, 90, 120 minutes, or whatever we want to achieve. And then the sides that are exposed to fire, and if the fire comes from the bottom and also the lateral sides are exposed, then of course we click like those three. But of course, in this case, as I said from the beginning, we keep it as simple as possible. I'm just going through each tab. We don't have like a fire load. So of course we can select, the concrete aggregate, the reinforcement class, manufacturing style, the pre-stress reinforcement class and manufacturing style, and also the epsilon values. Now the last tab, this one makes reference because pre-stress is a sectional calculation software. So in this regard, he will automatically calculate in those sections the value of my results. So if I want to have something like in between two sections, because I'm really curious to see what's happening at 0.5 meters, then I can, implement additional sections here and then click add, and then they will be added, and of course they will be calculated. So now you have like a more broader understanding on what is each tab doing, so it doesn't look so confusing anymore. Now, returning to the main reinforcement area, there are several ways in which we can define the reinforcement. We can do it manual by just filling in, numbers in this Excel table, like, or we can use the reinforcement pattern. We can use the layer of reinforcement, both in topping and in the beam. So as I said, multiple ways to do it. I usually use the layer of reinforcement because, as I mentioned in the last webinars as well, I always tackle another project to show you. I don't always calculate the same section or the same section shape. And that's why, you know, layer of reinforcement is more flexible in that regard. So if I click it, automatically I see that for a top reinforcement by default, I have a passive reinforcement, right? So I have a diameter 20 with a cover of 30 millimeters and the material is B500. Now at the bottom, the situation is changed because I have tendons. So as I see, I have a 12.9 diameter selected by default. Of course, I can modify it as well as I can modify any single value here. So let's go with, you know, 4 bars at the top and 6 bars at the bottom. Now, I see that the reinforcement is grouped, and the reason why it's grouped is because I didn't click in the calculation settings to use an equivalent distance between tendons. So therefore, let's go with just one layer of tendons and the passive reinforcement on the top, right? And let's see what happens. So I see that by default, again, prestressed has placed a value of 1,300 megapascals for each tendon. Of course, this value can be modified as well as the material itself. So if I want to modify it, it's easy. I just click it, you know, and just change the value from my keyboard. And now it's 1,100. So yeah, everything, almost everything is you can edit and modify. Again, with the coordinates. So the reinforcement are defined in a 3 coordinate system in a 3D way. So therefore, if I look here at this longitudinal section, I see that the plane is XZ, right? So the X gives me the length, right? So the starting point. And therefore, we will see later that sometimes I need to modify this. I need the reinforcement not to start all the way from the beginning of the beam. I want to start a little bit inwards. So that can also be, you know, modified. If I do this now, it will make it will turn red because my length is still 10 meters, right? But I shift it like 1 meter inwards. And then if I want it to be correct, so if I wanted to go all the way at the end of the beam, I should, you know, say 9,000. Or if I want it to be symmetrical, like in both sides to start from, you know, 1 meter inwards, I then select 8,000. And in this transversal section, I can see it because the transversal section, as you can see here, is indicated by those 2 arrows. And if I double click it, it will open up and it will show me that this reinforcement is not there because it's 1 meter inwards. So if I do this and drag this section, you know, like here, and I double click it again, I see that my reinforcement has reappeared as expected. So yeah, that's how you modify the length and, you know, the coordinates. It was just an example. You can do that as well with the YZ coordinates if you want to tweak a little bit the arrangement or something like that. Then again, we can play with the material. So in the material, as I see, I have this, is it called 7 wire super strand, right? So if I click the database, I can see that I have this button to create a new material. And here I just have to fill this input data like the modulus, the epsilon values, and so on, and I can create a new material. So, and also the bar type. So that's how you do it. For those examples, we will stick with the default values, but in case you need it in some project, that's how you do it. Okay, then what is the next step? Well, of course, we created some longitudinal reinforcement, but we haven't created any stirrups. Now, here as well, I have multiple options to define the stirrups. I can click this one and say automatic design of stirrups. I can place default placing, which I usually do. So I usually start, with a default placing, and if I feel that I want to have more stirrups, for example, towards the ends of the beam, I just modify the distance between them, and then I have more. So yeah, we can, of course, modify those as well. The same, where is the position in the beam, in the topping? So yeah, we can play with it, and we can also visualize the stirrup here in the transversal section. So yeah. Now we won't bother with the rest of the tabs. We will just move to the next step. So now we have defined our reinforcement. We move a little bit down. So moving down means the load combination. By default, I have two, because if you remember at the beginning of the project, there was an option which was clicked by default to automatically add the dead loads, like the self-weight. So this is the self-weight of the beam, and this is the self-weight of the topping. Now, I don't have any other loads except those. Also, as I can see here in the load combination, B2, which is the weight of the topping, is not added nowhere. So how do we fix that? Well, first thing we need to do is to go to each individual phase. So let's start with the release, which is the first one. And what we need to do, we need to set an exposure class, right? So we will set an exposure class, like moderate humidity, and then we should actually select the strength class. Now, keep in mind that the strength for a precast element, it is progressing. So it is progressing towards the storage. Storage, which in which stage the beam will stay, like in the yard, in a storage facility, and it will reach its full capacity. So by the time it reaches the transport stage, it will have the final capacity, right? So in this case, by default, it is selected to be C40. If we want to change it, of course, we can change it, but then we have to take into consideration also the leap from the release to the transport to match this class, right? So, of course, we do not let it, if I want my final class to be C30, then this one should be lower, right? So this one probably should be C20 or something. So keep that in mind when you modify that. Basically, those first three stages are really important on how you set the class. And then I see another window, which is the topping, right? And I see that it is selected as none, meaning that in the first phase where I activate the topping will be wet, and afterwards automatically prestressed knows that in the follow-up phases it will be already hardened, so it will be cast and it will select automatically. So let's assume that in this intermediate stage right? After we have placed our elements in position in our structure, we cast the topping. So this is the phase where I want my topping to be wet. In this particular phase, it will only act as a load because it's not hardened yet. But if I check the next phase, I see that it's hardened, so it's casted, right? And again, I have this material topping in which I have to do the same thing that I did for the material of the precast element, meaning the exposure class and the strength class. Now, because I now have those defined, I can go back to my load combinations. And again, I see here some tabs, long-term parameters, long-term parameters for the topping, which is basically the creep and shrinkage. Now, I know that some of you already know, but some of you don't. So therefore, if you write creep and shrinkage StruSoft in your browser, you will then find this tool, right? Which is the calculator. And here, oops, here you can calculate your creep and shrinkage factors, but of course you will have to fill in some input data. And then you have the show calculation here. You can copy it, you can do whatever you want, but those two factors you need to insert here in the long-term parameters tab. Of course, you can do it without them as well if you just want an, let's say, approximate result. But my honest recommendation is to use them as well. Now, of course, I don't have more. So what I should do, I should go into this input loads and go to load cases. Of course, in this input load, as you see here, I have the self-weight of the beam, which is present in all stages. But I need to go as well and define some additional load cases. So if I clicked on that load cases button at the top, I can then select more. So permanent load and maybe a live load, right? And I can set it like office. And now I can choose the load case, as you see here, live load, and I can add it. So, but I can only add it one by one. So the live load, for example, probably comes from the final stage, right? And I can either select a uniformly distributed load, linear distributed load, or point load, or self-weight, right? So let's select something like 3 kilonewtons per meter, as I have no idea how it will behave. Yeah. And then, of course, you can select like how the load is distributed, if or not it does have an eccentricity and so on. But as I said, for this model, we want to keep it as simple as possible for you guys to understand the flow of one calculation. So then I go to the permanent, and maybe the permanent will be present from the intermediate stage, and I want it to be 5. Okay, and now I just want to check them, let's see, permanent, self-weight topping, live load, and yeah. So now we are good. We have our loads. We can do the load combinations, right? So let's start with the intermediate stage. In the intermediate stage, I know I have the topping and the permanent, right? So I click change. Then starting from the final stage, I have everything. And I see that the software automatically adds the safety coefficients, which for some of you, they might be different. Because you have a different safety factor in your national annex, or for whatever reason you want to change it, you can do so by changing it here and then click change, and it will change to your desired safety factor. Okay, so now we have defined our load combinations. We have defined our exposure class, strength class. Now, basically, we can go and simulate a calculus. So if I go and click on the analysis to analyze, it will analyze it from a static point of view first, and then it will do a design check. So now I can view, like the moment, shear forces, torsion, etc., deflections, and so on. And if I am satisfied with them, here is where I check the rest of them, right? So I can declick and re-click just to see one of them. The next step would be to go on design, calculate, code control. Concrete strength is too low compared with the requirements of the selected exposure class, right? So I see that I have an error already, but as I see from those red lines, I have more. So of course, I can go and quickly check it by clicking this result code check and see what's going on in my beam, so that I can fix it, right? So I see that the compression strength is higher. It's 1.3. Decompression cover check, this can be ignored. Then let's see in final stage long term. Yeah, again, we can ignore it. Shear capacity in the topping. So as I said, topping joint capacity, again, exceeded. So we should go back and select it, maybe indented and not rough. As we can see, the topping joint capacity is exceeded in this case. So yeah, of course, now I will reiterate the calculation, impose some modifications, right, and redo it to see if whether I fixed everything or not. But basically, what I wanted to show you with this flow is for you to get a feeling what you need to do. Of course, as for every single model, we need several iterations and several, small modifications until we reach the optimal design. Now, one thing that I didn't mention, and probably a lot of you are asking, is about the position of the supports. Now, the position of the supports is placed in the most common way possible, but of course, those can be also modified in each phase, right? So if I go, for example, in storage and maturing, and I just double click it, then I can, of course, modify the distance and place it wherever I want. So yeah, okay, so let's see if we have some questions so far. Why transport SLS is not multiplied via 1.4? Yeah, so as I said, the safety factors can be set to whatever value you want. So that can be, defined by you. In my case, for example, I'm from Romania. I don't have like in the final stage all the and all live loads are like 1.5. Tobias is saying that he can see that Let me see if whether I can make it bigger so I can read it. He can see that the wire is set to 100 square millimeters, isn't the surface of 12.9, probably a different value. Yeah, so to be honest, I haven't calculated it myself, but so this is how, sorry, it's a little bit new for me because they changed the interface in GoToWebinar, so I couldn't see your exact question. Yeah, now I can see it. So also, Tobias, you have to take into account that those are usually like 7 wires, so it's not like a full circle, and therefore there are differences there, and those are usually given by the guy that is making the wires, which is the area. But of course, they can be calculated. If you know the diameter of one wire, you just multiply it by 7 and you get the final answer. Okay. Is it possible to change the stirrup type to get more legs per stirrup? Yes. So keep in mind that this calculation is made in the case of stirrups. So the shear plane intersects a number of legs for a certain distance. In this case, if you apply a load close to the support, it will be the distance between the support and the applied load. So if I want to have multiple legs per stirrup, what I need to do is just understand how many stirrups do I have in that interval of distance between the load and the support, and then just make it that even if my stirrup has 2 legs and I want, for example, to have 4 legs, I am just cutting the distance between stirrups in half, and you will get the same value, because mathematically it's the same number of legs intersected for that specific interval. I hope I was clear. If not, you can come back to me after, and I will explain it yeah, in a way that everybody can understand. Yeah, I will take a few more questions, and then for the rest, please address them on email, because otherwise I will just waste all the remaining time to answer some of your questions, and I cannot go through everything that I have proposed myself to show you guys today. So please reach out to me by email, and I will gladly go into a one-on-one session, or just simply answer, give you the answer via email. All right, so I have a few models which I prepared, and I realized while I was just going through some models today that in all my past webinars I forgot to mention something about holocore design, and I can show you immediately what. So this is like a model that I made academically for a holocore design. This is the reinforcement arrangement. I placed like a bogus topping on top just to check something out. But the most important thing is if we go on the calculation settings, and I always told you to check if whether this is the shear calculation without shear reinforcement is clicked. But I never went here into the composite web shear capacity. So this is very interesting, because let's leave it unchecked for now. Do the calculation, remember the shear value, and then check it. Because what is this option actually doing? It says if you hover your mouse over, If topping is active, the shear capacity for the hollow core will be calculated as a composite capacity according to EN 1168 for web shear failure. And it says, note, this capacity replaces any shear capacity for the hollow core calculated from EN 1992 per 1, or its alternative 1168, right? So this is really important when the shear calculation is not okay. You know, this by clicking this option, it will increase because it will act as a composite. So as I said, for now, let's run the calculation as it is. So I have also defined the load, you know, some permanent loads, some topping, some live loads, so we can perform a calculation. All right, let's go to the design now and calculate it. We just ignore it as I said, it's an academic model, so we will ignore the failure to achieve convergence. We could close. Oh, of course, in your models, which are not academic, you will not ignore any error. But in this case, yeah, we can do that because I want to show you something different. So if we go, for example, in final stage A, we see that the shear capacity is 0.274, right? And the shear capacity in topping is 0.178. Now, try to remember those values, because what we are going to do now, and the only thing that we are going to change is that option that I showed you. Where is my, don't do this to me, please. Here it is. Okay. Come on. It's in the back somewhere. I do have this error sometimes when I'm sharing my screen, that it totally disappears on me. So I will just reload the model and check that. Let's see. No. Sorry, but sometimes it happens. Probably only on my computer. I don't know. It's some setting that it doesn't like. And when I'm sharing my screen and I am in a webinar or in a one-on-one call, it does that sometimes. So yeah, now we have our model. Now everything is working again. And as I said, the only thing that we are going to change is in the calculation settings, this one. So now I clicked it, and we will analyze it again. And I hope you remembered the values for shear. What is this? Okay. And of course, the most important resource that you have at your disposal is the prestressed wiki. Like here, you can literally just use this magnify glass, you know, and just type whatever you want, long-term parameters, right? And then I see all the results. So I just click it, and it will explain to me what are the long-term parameters, how they are defined, etc. And everything basically you can find here. And trust me, there are times, a lot of times, when I'm also using it, even though I'm using prestress for years now, I'm still using it because I don't want to memorize by heart some things. I know it's there, and I can reach it very easy. Yeah, so now we do the design check. And again, we have like this error. Okay. And if I go to results, code check, we go to the same phase, final stage A. We see that now my shear capacity has changed. If I'm not mistaken, it was 0.274. Now it's 0.389. Of course, the design section is also changed because it's no longer that particular section, which was 0.17. But the shear capacity has changed for my beam. So therefore, there are cases in which just by clicking that option, it may or may not save your design. So as I said, I realized when I was preparing this webinar that this is something that I might have slipped in the other webinars, and that's why I brought it up so I don't forget. Now, as I promised, I have more models to go through. So in this particular model, I have different tendon lengths. So as I said, if you remember the first model that we did from zero here, we had the compression check was not satisfied. So meaning that, our tendons were pressing too much that it exceeds the compression strength of my section. And when that happens, usually in reality, we placed some non-adherent tubes in the beams, and we move the second row of tendons, for example, to a different section. So we don't get, like the end of the beam to be completely cracked, or to have like a anchorage bond failure, and so on. So how do we simulate those non-adherent tubes? Well, simply by defining what I told you in the beginning, that we move the start and end of the tendon. So as we see here, from the reinforcement number 7, my reinforcement starts at the position of 1000 millimeters inwards, equivalent for 1 meter, right? And I think I only had 2 rows in this one. Yeah. So again, if I click here, I see that I only have 1 row, right? And if I move this section, I now have 2 rows of reinforcement because I moved them inwards. So that's how I simulated the non-adherent tubes. Okay, let's see. What other models do I have that they are really useful? We have time for one more. So let's see. Maybe a slope tie beam would be interesting for some of you, as we often use it as roof beam. So let's see, how does it look? So it looks like this, right? And how do we define it? Well, if we go in the project, from that beam type drop-down menu, I see that I have here the sloped I-beam or the sloped TT beam, right? And then I can click configure, and here I can configure my sloped I-beam. And of course, I can click those two sections and configure my sections and everything in between, like, you know, the slope, the distance of transition from a rectangular section to an I section, and so on and so forth. So we can define mostly everything, the height of the beam, etc. So yeah, let's go through some more questions to see if we have. How do you use the software for slabs? Well, if you remember, I showed you the holocore one. So basically what you have to do is just, you know, select a constant section and then select like a holocore slab. If you want to use it for like a simple slab, you know, you just use it as a rectangle in the other direction, not with the height as being the dominant, with the width being the dominant. Yeah, let's see. Aronas, I'm not sure I understood. You said, could you explain the adjustment factors based on practical tests, please? I'm not sure I understand the question. So if you are making reference to the safety factors or something else, of course, it will multiply the load by that safety factor, if that's the case. So yeah, but you can do a test on your own just to modify it and see how it reacts. And, you know, maybe just modify it to a very big value, like a 3 value, and then go back to 1.15 or 1.35, and you can see, you will see the difference. Let's see. Somebody has asks if whether we have a comprehensive single manual document for the software. Well, the prestressed wiki is quite a you know, useful tool. Of course, the software does come with a manual of when you install it, and I think that most of, you know, examples or and, you know, all the webinars are being uploaded to YouTube and go to stage. So I say we have quite an extensive knowledge database in this regard. Plus, you always have like if there is something that you cannot find by any chance, you can always make a ticket to our support team, and, you know, they will come back to you with the answer in a very short time. Do I need to check the data value in the end capacity? No, you don't, unless you want to modify it. Is there a big difference in placing in the topping as a load or adding it in the input if you want to avoid errors with the topping? Well, here is the catch. If you just add it as a load, it will not take any stress whatsoever. But if you model it, the topping, then it will contribute, right, to the way stress is being distributed, because a part of it will go to the topping, of course. So in that regard, it's always more accurate to model it than to just add it as a load. Yeah. So guys, as I said before, if there are questions that are, unanswered, or you have some particular models that you would like to address, please create a ticket and for our support team, and they will answer shortly. If not, you can send an email to me, and it's fine. Yeah. So thank you for today's webinar, and I'll see you in the next one. Bye bye.